The next thing we're going to discuss is the distance formula. Sometimes we want to find out how far 2 points are from each other. Before we can get into that, we need to remind ourselves of what the distance means to a point. Well, if I have the point there, the distance is what we actually talk about, is the distance from the y-axis to where that point is on the x-axis. The distance from here to here is 2. That's why that has the coordinate of 2 for the x-coordinate. And the distance from the x-axis is 0, so that's why it has the distance of 0. If I take an arbitrary point and just put it over here, and I call its coordinates x1, actually I'll call that one x2, comma y2. You'll see in a minute why we use that. Well, that means that the distance between here and here, just like this was 2, the distance between here and here would be x2. And the distance for my vertical distance is the distance between here, and that would be y2 for the distance. So the actual coordinates of the points are telling you the distance that that point is from the x-axis or the y-axis. I'm going to put another point, and I'm going to call it x1, comma y1. And the question I want to answer is how far these 2 points are from each other in a straight line. Well, we know that the distance between here and here is x1, and the distance between here and here is y1. So we're going to go back and we're going to use the Pythagorean Theorem that you learned in middle school and covered again in geometry and algebra 1. What I'm going to do is I'm going to extend this line, and I'm going to make a right angle, so I now have a right triangle. Well, in order to find the length of the hypotenuse of the right triangle, I need to know the length of that segment and the length of the vertical segment, which I will now put in blue. So let's do this segment first. Well, in order to find the length of a horizontal segment, what I need to know is I need to know what this distance is. Well, the coordinates for this point right here would be the distance between here and here. Well, that's the exact same horizontal distance as between here and here, so it's going to have a coordinate of x2. For its vertical distance, well, the distance is the same vertically as from here to here, which is the same as this one, so that would be the vertical distance y1. So if I want to know what this distance is, if this total distance is x2, I'm going to erase that for a second. If the total distance between here and here is x2, and the distance between here and here is x1, this is the remaining distance that I want to find. Okay? And in geometry you learned that, hey, all I have to do is say that this segment plus that segment is that one, so the distance between here and here is actually going to be x2 minus x1. And I can use the exact same relationship to find out the distance between here and here. If the total distance is y2 and this distance is y1, the remaining distance is going to be y2 minus y1. So now what I'm going to do is set up the Pythagorean Theorem, and I'm going to call this d for my distance that I want to solve. And the Pythagorean Theorem said that the square of the length of the hypotenuse is equal to the sum of the squares of the lengths of the 2 legs. The length of one of my legs is x2 minus x1. The length of my other leg is y2 minus y1. And I don't want to know what the distance squared is. I want to know what the distance is. So I'm going to take the positive square root because distances can only be positive. So the final distance formula is x2 minus x1 quantity squared plus y2 minus y1 quantity squared, all underneath the square root symbol.